All right. Hey y'all, my name is Brooke Keadle, and I'm a master's student here at the University of Tennessee. And today I'll be talking to y'all about winter oilseed crops, which are potential dual-use cover crops for Tennessee. So first, based on that title, you're probably thinking, what are winter oilseeds? Because I know I did when the project was presented to me. So winter oilseeds are annual cool season brassica crops. They're grown in the fall through the winter. They can be used as what we're going to call cash cover crops, which are also known as dual crops. They produce high oil content seeds, and they're currently being adopted in Midwestern conventional agriculture. So we want to see if they work here too. So now you know what they are. Why should you care? You should care because there are numerous ecological benefits from cover crops, but there's no direct economic gains. So a lot of farmers will forego planting cover crops just because they're not seeing that immediate economic gratification, even though down the road, the soil health benefits and soil protection will save them money eventually. However, winter oilseeds provide ecological benefits of a cover crop as well as an added economic benefit of a second cash crop in one season. But currently there's unknown yield potential in our region. Most of the research is in the Midwest. So that's why you should pay attention to my study here and see how they're working in the Mid-South for us. There are many uses of winter oilseeds. They can be dual cropped in a corn and soybean rotation. So they'll be in between the corn and soybeans. They have all the benefits of winter cover, including lowering erosion, nutrient catching, and creating a new pollinator habitat. They can be used for weed control, possibly through allelopathy, and the seed can be sold to create biofuels, including jet fuel. So that's an exciting avenue of sale. The objectives of my study are fairly simple. We're trying to figure out, will these crops grow here in our climate? And then we want to find out which cultivars grow the best in our climate, as well as determine if there's any effects on the crops grown after in rotation with the winter oilseeds. So that leads me right into my study. So first off, let's meet the species we'll be looking at. So here we have pennycress, canola, camelina, and here's a different size comparison. Pennycress is currently being grown in Illinois and Minnesota, and both are doing plant breeding research there. And canola is currently grown all over the upper Midwest, and camelina is not commercially grown, but it's being tested in the Oregon area of the upper West over there. And so to test these species, I created a design that we're testing in Highland Rim as well as the Myland here. And we're looking at both tilled and no-tilled trials of these three species. And we're looking at 3 varieties of each species as well. The seeds are drilled in late September, early October for these trials, and they're grown in between corn and soybeans. I'm going to run through really quick all the data we collected because there's a lot of it. So in December of both years of this study, it's a 2-year study, and I'll just be going over the results from the first year because I just finished the second year, but we're not done quite yet with the research or the analysis. So in December of both years, we looked at the percent ground cover and the percent weed cover in these squares per plot. In May and June, during harvest, we looked at agronomic traits, including height, shattering, lodging of the crops, as well as yield data. After harvest, we looked at soil moisture in the plots, as well as took soil samples to look at nutrients in the plots. In July, we threshed the plants that we collected from each plot to look at seed oil content, as well as glucosinolates. And then in October, we planted soybeans after harvest. We harvested the soybeans in October and looked at the bean quality there. So lots of data, but let's get into the results of what we found because of all of that. First and foremost, camelina had to be excluded from these results for the 2020-21 growing season because they all died. I think we had a really warm winter in 2020, so those plants bolted early, and then when we had our first frost, they were all killed off. But so we'll be looking at canola and pennycress data. And so for winter cover, tilled canola had the highest amount of cover here at 88%, followed by no-tilled canola. And then pennycress showed the opposite trend, where here we have the no-tilled pennycress a higher percent cover than the tilled pennycress. And then for weed percentage in the plot, pennycress had much more weed percent than canola. In the spring at harvest, for yield, canola followed the same trend as it had with the winter cover, where this tilled canola had a higher yield than this no-till canola. While pennycress deviated from that trend, and they both had similar yields across tilled and no-tilled. There were no variety differences within the species, so all three canola varieties yielded the same about as each other, and then all three pennycress varieties yielded about the same as each other, except for spring type was numerically much lower. During harvest, canola was much easier to mechanically harvest with a combine. And however, much of the pennycress seed blew out of the combine. Research from the Midwest says that this is common, however, and that in order to harvest a substantial amount of pennycress seed, you need to really seal up the combine, like every crack and crevice. And we didn't do that. So that would explain what happened there. And so just to alleviate any bias with the combine, all these yield calculations are based on hand harvested squares and not the combine. Oh, and one more thing to point out is that these canola yields are above the US national average as reported by the USDA, which this year was around 2,000 pounds per acre, and we are well above that at nearly 3,000 pounds per acre. And so now we'll move on to soil health. Based on our soil moisture and our nutrient analysis, we couldn't find any trends. I've looked at these over and over, and there's no trends to be found with these two significant graphs here. And so we're thinking that the differences in soil health parameters are likely due to long-term management in the field, especially since the winter oilseeds have only been grown there for 1 year. So now we can move on to the oil analysis. And here we have 30% oil content in the seeds is considered high and competitive in the biofuel market, and both species exceeded that. And so you can see here we have almost 50% oil content in the Phoenix canola and around 33% in both pennycresses. So that's great. And oil content is determined by the weather and the climate during seed filling. And so this shows that our average Tennessee environment is conducive to producing high oil content seeds. We also tested the glucosinolates present within the canola and pennycress seed. Here you can see that canola has much lower glucosinolate content than pennycress. And that's because these glucosinolates have been bred out of the canola. Allele chemicals that can suppress weed growth are typically found within these glucosinolates. And then glucosinolate content will also affect your ability to sell the seed meal as animal feed. So another avenue of sale for these. Next, we'll go to the soybean yield. Due to a planting error, we're only looking at the soybean yield from Highland Rim for this first year study. Soybeans following canola, so soybeans planted in plots where canola was previously grown, had a 5 to 6 bushel lower yield than those planted in the camelina, fallow, or pennycress plots. And then also we had about a 4 bushel difference between, so all soybeans were no-till planted, but they were planted in previously tilled plots. They had a hot 4 bushel higher yield per acre. than those planted in the no-till plots from the winter oilseed. So interesting difference there. And then we also ran the soybean oil percent and protein percent for seeds. And you can see we have the opposite trend for each. Tilled plots of winter oilseeds had higher soybean oil percentage than the no-till, while the opposite was true for protein percentage. And so that brings us to our overall conclusions. So after just 1 year of study, we have promising preliminary yield results for pennycress and canola. Both are meeting the national averages or current research yields. Canola appears to be much better adapted to the Mid-South than pennycress or camelina. However, canola has undergone a lot more breeding than the others. And so our next steps are to complete our find out how they all do. I'm hopeful that they're growing pretty well and they could possibly be a good avenue for our growers here to make some extra money and protect their soils. And with that, please feel free for my folks online, please feel free to reach out with any questions. I appreciate your time, and here's my contact information. Definitely email me with any questions you have. Yeah, thank you.